Okay, we now have equal to root h1 is 9 times root 2. So now this thing will give you final answer as 9 root 2. That is the answer. Then the second one, which is the I. So we now have root 54. This will give you root. You check a number that you can multiply to get 54, and one of it will have a square root, and we notice 9 times 6. So now 9 times 6 will give us 54 equals to root 9 times root 6. So now we have equal to root 9 is 3 times root 6. So equals to 3 root 6. So I'm just giving this thing as a preamble, introductory part of it. It's something that I'm expecting that many of us should know. So we have not even entered the major part of it that is somehow difficult. So I'm just using it so that it can be a stepping stone, so that we can be able to do justice to the others we are going to be solving. So now the last one before now we forge ahead, we have root 98. And root 98, you check a number that can be able, the way I have been doing it, you now have root 49 times 2. So it's now left for you to check, think, and know the number that can be able to be splitted to get the exact number that is inside the original root. So you now have root 49 times root 2. So this will not rightly give you 49 has a square, which is 7 times root 2 equals to 7 root 2 as your answer. So that's how to simplify any this thing solved using those two laws or basic principle rules I've given initially. So let's go into what we call conjugate surds. So this one is just simple. When I talk about conjugate surds, some will be asking, what do I mean by conjugate surds? So surds are conjugate. For instance, if I have something of this nature, if I have maybe root a minus root b, the conjugate is simply the opposite sign. The sign is between them will change. So now be root a plus root b. So that's what I mean by